all. So in today's class, we will look into the mean value theorem. So first we'll begin with the geometrical meaning of mean value theorem. Then we'll see what is the statement and proof of the theorem. So you can see a diagram over here. So here you are given a function y equal to f of x. So here the function is plotted between the points a and b. So this is the point a f of a, and this is the point b f of b. So the dotted green curve, that is the curve y equal to f of x. Now you can see that the function is continuous and differentiable in the interval ab. So there is no break in your function. So you have a continuous curve, and this is also differentiable. Now the mean value theorem states that if you have a function which is continuous and differentiable, then when you take between any two points, appo nammal curve-ile രണ്ട് points edukkumbo, when you join the line joining those 2 points, so that is called as the secant line. So here we have the point f of a f of a and b f of b. Now you draw the secant line, so that is the line segment which is joining these 2 points. Now the mean value theorem states that there is at least one place where your tangent will be parallel to the secant line. Okay, appo idana nammada secant line. Appo namukku ee a kum b kum edakku there will be at least one c such that f dash of c will be equal to f dash of c എന്ന് പറയുന്നത് appo ഈ ടാൻജന്റ് ലൈനും സീക്കന്റ് ലൈനും പാരലൽ ആണെന്നാണ് മീൻ വാല്യൂ തിയറം പറയുക. സോ രണ്ടും പാരലൽ ആണെങ്കിൽ the slopes must be equal. So slope of the tangent line at this point will be f dash of c since the function is differentiable. അതുപോലെ slope of secant line എന്ന് പറയുന്നത് that will be f of b minus f of a by b minus a, അതായത് y2 minus y1 by x2 minus x1. That will be the slope of the secant line. So that is the geometrical meaning of the mean value theorem. So geometrically it states that between any 2 points of the form a f of a, b f of b on the graph of a differentiable function f, there is at least one place where the tangent line is parallel to the secant line which is joining the points a and b. So our tangent line will be parallel to the secant line. Now you can have more than one such point. Appo namukku for example ivide oru tangent line eduthu kayinal, again the tangent line at this point will be parallel to the secant line. So there is at least one point where the tangent line at that point will be parallel to the secant line. So that's the geometrical meaning of the mean value theorem. So let us see the formal statement and the proof of the theorem. So let us state the mean value theorem. So mean value theorem states that, so let f be continuous on the closed interval ab and differentiable on open interval ab. Then there is at least one point c in open interval ab such that f dash of c is equal to fb minus fa by b minus a. Now let us see the proof of the mean value theorem. Now before going into the proof, so we'll see the motivation for the proof. Now the proof arises from the fact that, okay, so when you have the secant line parallel to the tangent line, so when you look at the vertical distance between the secant line and the tangent line, അപ്പോൾ secant line tangent line parallel ആവുമ്പോഴായിരിക്കും ഈ ഡിസ്റ്റൻസ് maximum ആവുക. So if this is the distance v of x, so if you are looking at your distance between the function and your secant line, അപ്പം f of x ഉം secant line തമ്മിലുള്ള vertical distance നോക്കുക. അപ്പോൾ ആ vertical distance maximum ആവുന്നത് നമ്മുടെ secant line tangent lineനോട് parallel ആവുമ്പോഴായിരിക്കും. So this is a motivation for the proof of the mean value theorem. So using this idea we will solve the or we will prove the mean value theorem. So the tangent line is parallel to the secant line where the vertical distance between the secant line and the graph of f is maximum. Thus, to prove, so mean value theorem, I am going to write it as MVT. So, thus to prove mean value theorem, it is natural to begin by looking for the formula of the vertical distance v of x between the curve y equal to f of x and the secant line joining the points a f of a and b f of b. So let us move on to the proof now. So for proving the result, first we will find out what is our expression for b of x. Meaning b of x maximum on the point secant line and tangent line will be parallel. So at that point the first derivative has to be 0 because you have a maximum at that point. So that will give us the required result of the mean value theorem. So first let us find an expression for v of x. So the equation of secant line joining a f of a and B, f of B is given by, so y minus f of A equal to, so slope will be fb minus fa by b minus a into x minus a. This is in the form y minus y naught equal to, so you have m into x minus x naught. So m value will be y2 minus y1 by x2 minus x1. It will be the value. So this is the 2-point form of the secant line. So we will get, so that implies y equal to fb minus fa by b minus a into x minus a plus f of a. Now the difference, so let us now write v of x. So the difference v of x between the height of the graph of f and height of secant line is, so v of x will be given by, so that is going to be f of x minus, now equation of secant line is fb minus fa by b minus a into x minus a plus f of a. So now since f is continuous in closed interval AB and differentiable in open interval AB, so the function v also is going to be continuous and differentiable in the open interval AB. അപ്പം f ബാക്കി ഈ കിടക്കുന്ന സാധനം ഒരു linear function ആണ്, polynomial function ആണ്, that is continuous and differentiable everywhere, and you have the information about f which is given in your theorem. So since f is continuous on closed interval AB and differentiable in open interval AB, so is v of x. So v of x is also continuous on closed interval AB and differentiable in open interval AB, and we have, so let us look at the value of v of a. So when x is equal to a, e term 0 agum, so this will be f of a minus f of a, so which is equal to 0, and v of b is going to be fb minus b minus a cancel out, so fb minus fa plus fa. fa cancel out, baaki namakku varga fb minus fb aayirikkum, so that is again equal to 0. So here v is continuous in closed interval AB and differentiable in open interval AB, and v of a and v of b both are equal to 0. So these are the conditions of the mean value theorem. So therefore v of x satisfies the the Rolle's theorem satisfies the hypothesis of Rolle's theorem on closed interval AB. So therefore by Rolle's theorem there is a point C in open interval AB such that v dash of C is equal to 0.